All right, welcome back to the deep dive. Today we're taking a look at two really fundamental ways that Python organizes information: lists and tuples.
And you've shared some great material with me. Your notes, they define lists and tuples pretty clearly, and they give examples of how to create them with that special Python syntax, how to work with them, all the operations you can do. And
Yeah.
then there's this really useful table that kind of sums it all up. It lays out the differences when you want to use one versus the other.
Right. So our mission today is to unpack all that.
Absolutely.
So we want to help you, the listener, really understand the core differences between these two and when to use them effectively. Think of it as like demystifying these tools so you can be more confident in your Python code when you're dealing with data.
Yeah, for sure.
So let's start with lists.
Okay.
What exactly is a list in Python?
Well, at its most basic, a list is just an ordered collection of items.
Hmm.
You put things in a list, and they stay in that order. But the really key thing about lists is that they are mutable.
Mutable.
That means you can change them after you create them. Like, you can add things to a list, you can take things away, you can even modify the things that are already in the list.
So that's kind of the big differentiator, isn't it? That mutability.
Right. I mean, that's what sets them apart from, other data structures.
So let's unpack that a little bit. What does that look like in real life?
Okay, well, imagine you have, a to-do list, right? You
Yeah.
start the day with maybe 3 things on it, and as the day goes on, you add more, you cross things off. That's kind of like a list in Python. It's dynamic.
I see.
And in terms of actual Python code, you have these built-in methods that let you manipulate the list, like the append method to add something to the end of the list, remove to take something away, things like that.
Got it. So in your notes, you make it really clear. You create a list using those square brackets.
Yeah, the brackets.
My list, element one, element two, element three. That's kind of the visual cue, right?
Absolutely. You see those square brackets, you know you're dealing with a list. And then you put your elements inside those brackets, separated by commas.
Makes sense. Okay, so let's dig into some of the key features that you listed out. You mentioned that lists are ordered. What does ordered actually mean in practice?
It means that the position of each item in the list actually matters.
Right.
It's not just a jumble. So you can access each element by its index, which is basically its position in the list, starting from 0.
Right. Python always starts counting at 0. It's got to be different, right?
Right. It's a bit quirky, but, once you get used to it, it's not so bad.
Yeah. So if I have a list of fruits, apple, banana,
Yeah.
mango,
Right.
fruit 0 would give me apple.
Exactly. Because Apple is at index 0.
It's like each item has its own little address in the list.
Yeah, a numbered address. That's a good way to think about it.
Makes sense.
Okay.
Okay. You also said that lists allow duplicates. Why would
Yeah.
why would that be useful?
Well, think about it this way. Let's say you're analyzing some data from a survey, right?
Yeah. Yeah.
And multiple people give the same answer. You want to be able to represent that accurately in your data, have the same answer show up multiple times in your list.
So it's all about accurately representing the data as it is.
Exactly. You don't want to, artificially remove duplicates.
I see. Okay, and then you have this feature, dynamic size. Lists can grow or shrink as you add or remove elements.
Yes, that's a huge advantage. I mean, you don't have to know how many items will be in the list beforehand.
Right.
You can just add or remove as needed.
It's very flexible.
Yeah, super flexible, makes them really powerful for dealing with data that can change over time.
Yeah, yeah. And then the last one is heterogeneous. What does that even mean?
That means a list can hold items of different data types. So you can have, strings, numbers, Boolean values, all in the same list.
All mixed together.
Yep, all mixed up. Makes them very versatile.
So like your example, apple, 42, true.
Exactly. You got a string, an integer, and a Boolean all in one list.
Yeah, so it's like a container that can hold all sorts of different things.
Yeah, a very handy container.
Okay, so we have this basic understanding of what lists are, how they work, and some of their key features.
Yeah.
Let's look at some of the common operations that you've outlined in your notes, starting with len.
Okay, so len, that's a simple one. It just tells you how many items are in a list.
So it's just a way to get the size of the list.
Exactly. Like, how long is this list?
Okay, makes sense. And then you have indexing, which we talked about a little bit.
Yeah, so indexing is how you access a specific element in the list, right?
Right. Using the square brackets again.
Right, the brackets and the index number.
Yeah. So my list 2 would give me the third item in the list, right?
Exactly, because remember, we start counting from 0.
Right, right. Got to remember that 0. Okay, and then you have dot append.
Yeah, so dot append is how you add an item to the end of a list. Like, if you have your to-do list and you want to add another task to the bottom,
Yeah.
that's what append does, just tacks it onto the end.
Okay. So in your example, fruits dot append grapes.
Right, now you've got grapes in your fruit list.
Okay, makes sense. And then dot insert.
So insert is similar to append, but it lets you add an item at a specific position in the list.
So not just at the end.
Right. You can say, put this item at index 2.
Like my list dot insert to 10.
Exactly.
And what happens to the elements that were already at that position or after that position?
They all shift over to the right to make room for the new item.
So it's like if I had 1, 2, 3, 4, and I do insert to 10,
Yeah.
then it becomes 1, 2, 10, 3, 4.
Exactly. The 3 and the 4 just slide over to make space for the 10.
Got it. Okay. Now moving on to removing items.
Yeah.
You have dot remove.
Right. Dot remove. This one removes the first occurrence of a specific value from the list.
So my list dot remove 3 would get rid of the first 3 it finds.
Right. And this is kind of important, because what happens if you try to remove something that's not in the list?
Oh yeah.
Your notes don't actually mention this, but in real Python code, that would cause an error.
Right, a value error, I think.
Yeah, a value error. And if you're not careful, that can crash your program. So it's always good to check if an item is in the list before you try to remove it.
That's a really good point. I'm glad you brought that up. So be aware of that, listeners. Okay, and then dot pop.
So dot pop, this removes and returns the last item from the list by default.
Oh.
Kind of like taking the top card off a deck.
Yeah. And you could also specify an index with dot pop.
Right. Exactly. You can say, my list dot pop 0, and that will remove and return the first item in the list.
Right. Okay, so we can also change the order of elements within a list using sort and dot reverse. Right.
Absolutely. So sort will arrange the items in the list in ascending order.
Okay.
And it does this in place, which means it modifies the original list directly.
So no need to create a new list.
Right. And it reverses the same thing, but it reverses the order of the items, also in place.
So if I have a list 3, 1, 4, 2,
right,
and I apply sort, it becomes 1, 2, 3, 4.
Exactly.
And then if I use dot reverse, it becomes 4, 3, 2, 1.
Yep. And this in place thing is important to remember, right?
Yeah.
Because if you need to keep the original list unchanged, you might want to make a copy of it before sorting or reversing.
Oh, that's a good point. Okay, so we've seen how to work with individual items in a list, but what if we want to do something to every item in the list? Like, how do we go through each one in sequence?
That's where looping comes in, right? You use a for loop.
Right, a for loop.
Yeah.
So you would say something like for item in my list.
Exactly. And then you put your code inside the loop, and that code will be executed for each item in the list, one after the other.
Okay, that makes sense.
Yeah.
That makes sense. So that's a pretty thorough overview of lists. I think we've covered all the basics there.
I think so, yeah.
Now let's move on to tuples. What's the deal with tuples? How are they similar to lists and how are they different?
Okay, so tuples are like lists in that they're also ordered collections of items. So the order you put things in matters, and you can access them by their index, just like in a list.
Okay.
But here's the big difference. Tuples are immutable.
Immutable.
Yeah, that means you can't change them after you create them. You can't add items, remove items, or modify the existing items.
So once a tuple is created, it's set in stone.
Yeah, it's fixed. It can't be changed.
Okay, so that's a huge difference, right? Mutability versus immutability.
Yeah, it's a fundamental difference.
So what does that mean in practice? How does that affect how we use tuples?
Well, it means that tuples are really useful for representing data that should not be changed.
Right.
Yeah.
Like what kind of data?
Well, think about something like the days of the week.
Yeah.
That's a fixed set of values, right? Monday, Tuesday, Wednesday, and so on. It doesn't make sense to change those values.
Right. Wouldn't want to accidentally add a new day to the week.
Right, exactly. So for data like that, a tuple makes a lot of sense.
Makes sense. Okay, so how do we actually create a tuple in Python? What's the syntax?
It's pretty similar to lists, except we use parentheses instead of square brackets.
So my tuple, element 1, element 2, element 3.
Exactly. And just like with lists, you separate the elements with commas.
Okay. Now, you had this really important point in your notes about about creating a tuple with just one element.
Ah, yes, the single element tuple.
Yeah, why is that? Why is that so tricky?
Well, it's all about how Python interprets the parentheses. You see, if you just write 5, Python sees that as the integer 5 enclosed in parentheses, not as a tuple containing the number 5.
Okay,
So to tell Python that you really mean a tuple, you have to add a comma after the single element. So it would be 5.
with the trailing comma.
Exactly. That comma tells Python, hey, this is a tuple even though it only has one element.
Okay, so that's a little quirk to watch out for.
Yeah, it can trip people up sometimes.
Okay, so we've got our tuples created. Let's look at some of the key features, especially in comparison to lists. We already know about immutability, so what else is there?
Well, tuples are ordered, just like lists, so the
Yes.
order of the elements is preserved, and you can access individual elements by their index, just like in a list.
Got it. And they also allow duplicates, right?
Yes, they do, just like lists.
Okay, so far it sounds like they're pretty similar, except for that immutability thing.
Uh,
But you also mentioned that tuples are actually faster than lists for certain operations. Why is that?
well, because tuples are immutable, Python can optimize them in memory.
Okay.
It knows that the tuple size and content will never change, so it can store and access the data more efficiently. Lists, on the other hand, need to be more flexible, which adds a bit of overhead.
So it's like Python can be more efficient with tuples because it knows they're not going to change.
Exactly. And this speed difference can become really noticeable when you're working with large data sets, especially if you're doing a lot of read-only operations.
Like what kind of operations?
Well, for example, let's say you have a dictionary and you're using tuples as keys.
Okay.
Because tuples are immutable, their hash value, which is used for indexing in a dictionary, will never change. This makes dictionary lookups much faster.
Oh, I see. So it's not just about general performance. There are specific cases where immutability makes tuples a much better choice.
Right, exactly.
Okay, and just to round things out, tuples can also be heterogeneous, right?
Yes, just like lists. You can mix different data types in a single tuple.
Got it. Okay, so let's talk about the operations we can perform on tuples. You mentioned that it's a more limited set compared to lists, which makes sense given that they're immutable.
Yeah, you can't do things like append or insert or remove because those operations would change the tuple.
Right. We can't modify tuples,
Mm,
but we can still get the length of a tuple with len, right?
absolutely. Len works the same way with tuples as it does with lists.
And we can still access individual elements using indexing,
Yes, indexing works the same way too.
but no modifying.
Nope, no modifying.
Okay, so what can we do with tuples then? What operations are available?
Well, you have dot count, which counts how many times a specific value appears in the tuple.
Okay. So like my tuple.count 20.
Exactly. That would tell you how many times the number 20 appears in the tuple.
Got it.
Yeah.
And you also have dot index.
Yeah, dot index finds the index of the first occurrence of a specific value in the tuple.
So like my tuple.index 30.
Right. And just like with dot remove in lists, if the value isn't in the tuple, you'll get a value error.
Right. So we have to be careful with that.
Yeah, always a good idea to check if the value is there before you try to get its index.
Makes sense. Okay. And we can still loop through tuples, right, using a for loop.
Absolutely. Looping works the same way with tuples as it does with lists.
So you could say for value in my tuple.
Exactly. And then you put your code inside the loop, and it'll execute for each value in the tuple.
Okay, great. So we've covered a lot of ground here. We've looked at both lists and tuples in detail. We've seen how they're similar, how they're different, and we've seen some of the common operations we can perform with each one. Now for the big question. When do we actually choose one over the other?
Yeah, that's the million-dollar question, right?
It really seems like the key deciding factor is mutability.
Yeah, I think that's the biggest difference. Lists are mutable, tuples are immutable.
So when would we choose a list?
You would choose a list when you need to modify the data. You know, if you need to add items, remove items, or change the existing items, a list is the way to go.
Right. So lists are for dynamic data that's going to change.
Exactly.
Okay. And when would we choose a tuple?
You would choose a tuple when you want the data to stay the same, when you need to guarantee that the data won't be changed, either accidentally or intentionally.
So it's all about data integrity.
Yeah, and also performance. Like we talked about earlier, tuples can be faster than lists for certain operations.
Right, especially when you're working with large data sets and doing a lot of read-only operations.
Exactly.
Okay, so let's think of some real-life examples.
Okay, good idea.
When might we use a list and when might we use a tuple?
Well, let's say you're building a shopping cart application, right?
Okay.
The items in the shopping cart, that's dynamic data. People add items, remove items, change quantities. So you would definitely want to use a list for that.
Yeah, that makes sense. What about a tuple? When would we use a tuple?
Well, think about something like the coordinates of a point on a map.
Okay.
That's usually a fixed pair of values, latitude and longitude. It doesn't make sense to change those values.
Right.
So a tuple would be a good choice for that.
Makes sense. Makes sense. Okay, so to recap, the key takeaway here is that lists are for dynamic data, data that we need to be able to modify, and tuples are for fixed data, data that should not be changed.
Exactly. And choosing the right data structure can make your code more efficient, more reliable, and easier to understand.
Great. So as we wrap up our deep dive into lists and tuples, is there any final thought you want to leave our listeners with?
Yeah, I think the key takeaway here is that both lists and tuples are really powerful tools. They each have their own strengths and weaknesses, and it's up to you, the programmer, to choose the right tool for the job. So, take some time to really understand these data structures, experiment with them, and think about how you can use them effectively in your own code.
Yeah, and as you continue to write Python code, maybe start paying attention to how you're using lists and tuples.
Yeah.
Are there places where you could switch from a list to a tuple to make your code more efficient or more robust? It's a really interesting thing to think about.
Absolutely. And this whole idea of immutability, it's not just about lists and tuples. It's a really important concept in programming in general. So, the more you can understand and embrace immutability, the better your code will be.
Excellent. Well, thanks for joining us for this deep dive into lists and tuples. We hope you learned something new and that you'll join us again next time for another deep dive into the world of programming.
Thanks for having me. It was a pleasure.